We start with the chapter 1 of the matrix operations book. We continue where we left last time, and we were about to find the dot product of two vectors. So here three vectors are given, a, b and c. A and b are column vectors and the c is a row vector. So in order to find the a dot b, and usually because this will happen when we are like in a set, we have all vectors of the same kind, so we can find the product. So if they are of the same kind, means they will be of the same order. So here a is of order 3 by 1 and b is of order 3 by 1. So we can find something called a dot product of the vectors. So what is a dot product? One thing you have to remember, that the dot product is going to be a scalar, means a number, so not a vector. So this always yields a number, the dot product. So a dot b will be equal to, now I am going to write this step. You may not write it like this when you are doing for the exam, but for now in the beginning, just to get an idea of how this works, it's a good idea to write this. So now you have this, and now you are going to multiply the corresponding entry. So this will get multiplied with 5, 3 will get multiplied with 6, and 4 will get multiplied with -7. So that we end up getting 10, and then we add all of them. 10 plus 18 and plus -28, which gives me -28. When I add everything, I get a 0. So 0 is a number, so we are not going to put a bar on top of it, just 0. So the dot product of these two vectors is giving us a 0. Now the next thing is asking us to find the b dot c. C transpose. The t up there means transpose. So it means this is of a size 3 by 1 by 3. This is of order 1 by 3. Now C transpose will be this. So C transpose will be of order 3 by 1. So we can find B dot C transpose will be equal to, so again we can do it without writing this, but I think it will be easy to write and see. So we get 5 times 7, 35. 6 times 8 is 48, so -48 plus -7 times -9, 63. So plus 63 gives us, if we add 50. So we are getting a number. Okay, now we look at algebra of matrices. So if we have two matrices A and B, and we want to find the sum or add the two matrices, one thing is that they should be of the same order, which they are. And how do we add them? We add the corresponding entries. So the 1 will be added to 3 here, 2 will be added to -3, and so on. And we end up getting the matrix over here. And note that the sum matrix is the same order as the two matrices that we were adding. In short form, we can write it like this. Okay, the next operation or algebra we do discuss is the multiplication of a matrix by a number, by a scalar. Okay, scalar means a number. So here we have a matrix, I think this is the matrix B. So we are multiplying it with -2. So what is -2 times B? So what we do, we multiply each and every entry by the number, by the scalar. So -2 in this case, so notice here we obtain that one. So again, this is of the same order. So when you multiply a matrix by a number, the size or the order of the matrix doesn't change. So here we have K times the matrix, whatever Aij in general, then this will be equal to K times Aij. So K goes inside the matrix. Now note here, when we have like negative A, it means -1 times A. So if you want to find, for example, A minus B, what that is A plus negative 1b. So in other words, a minus b is the same as adding the entries of a to the entries of negative b. Okay, some more properties of addition and then scalar multiplication here. So this property is called associative property of addition. It means if you have three matrices, it doesn't matter which two matrices you add first, and then you add the third matrix to it. Commutative property means if you add A to B or B to A, you get the same answer. You will note in multiplication this doesn't work. But anyhow, so A plus O, what is the O? O is the zero matrix, so A plus O is always going to be A. So this is like numbers, like 2 plus 0 is equal to 2. So matrices also behave the same way. Then A plus negative A will give us 0. So this is again the same as 2 plus negative 2 is equal to 0. So it behaves like matrices, like numbers here. Matrices have the same properties for addition. Then R times A plus B will be equal to RA plus RB. So R is the scalar, and if we have the sum of matrices being multiplied by R is the same as if we multiply each matrix by R and then add. In the same way, the property number 6 is saying that R plus S. So if you have two scalars and you are multiplying the sum of the scalars with the matrix A, it is the same thing as if you multiply the matrix by each of the scalar and then add them. The seventh property is that R times SA. So if you have a matrix A and you have already multiplied by a scalar S, and now you are multiplying it with the scalar R, it is the same thing as if you first multiply it by scalar R and then with S, because S and R can commute. What about the matrix multiplication? So this is kind of a little bit different than what we just saw with addition. The first thing is we can not multiply any matrix with any other matrix. There has to be some conditions or restrictions that have to be observed. So the two matrices A and B can be multiplied to form a product AB only if the number of the first column, so the number of the first means the first is which is the matrix written on the left, and the second will be the matrix on the right. So if I am looking at BA, that is different from AB. So this will be the left matrix and this will be the right matrix. So the number of the first one or the left one should be, the number of columns of the left must be equal to number of rows of the second. So for example, if you are trying to find AB and A is of order 2 by 3 and B is of order 3 by 2, we want these two numbers to be the same. So once they are same, then we can find the product AB. And what will be the size of the resultant? So let's say AB gives us a matrix whose name is C. Then the order of C will be whatever is left over. So 2 by 2. First this 2 and then this 2. So let us see here some examples. So the first one is saying we are given A, B, C, D. Find 3A minus 2 over 3D. So here you can find them separately first, and the work you need to show here. This is how you should be doing it. So 3A means I multiply every entry of the A by 3. 3, 6, 0, 9, 3, negative 9. Now 2 over 3D. Now I can do 2 over 3D or I can do negative 2 over 3D. I think it's easier to do 2 over 3D. Will be equal to 2 over 3, 4 over 3, and 2. 8 over 3, 9 over 3 will give me 6. 7 over 3 will give me 14 over 3. So 3A minus 2 over 3D will give me, so note it will be the same order as A and D, So I have 3 minus 2 over 3, 6 minus 4 over 3, 0 minus 2 over 3, 9 minus 8 over 3, and then I have 3 minus 6, and then negative 9 minus 14 over 3. Now we just find these values and we get our answer. So here I am getting 7 over 3, value 14 over 3, and negative 2 over 3, 9 over 3, oh, 27 minus 8, 19 over 3, and then 3 minus 6 is negative 3, and the next one is negative 27, negative 14, 41. So I get negative 41 over 3. Okay, note here that over here you can see that the 3 is almost in every denominator except here. So if I rewrite this as negative 9 over 3, then I can actually pull out 1 over 3 from the matrix. I mean, it's not necessary that we do that, but maybe in some cases later on you will see we might have to do that. So this is what scalar multiplication gives us. Okay, so now we have to find the products. So A times C. First thing we have to note is, can we do it? Can we find A times C? So we look at the size of each matrix. So A is of order 2 by 3 and C is of order 3 by 1. So these two numbers are same, so yes, we can multiply them, and the resulting matrix will be of order 2 by 1. So it means that this will be a vector like 2 by 1 of size like this. An entry here and an entry here. So how do I multiply it? It's better to write the two matrices side by side. Okay, so this is how we go in here. We will first multiply the first row with the first column. Well, there is only one column here, so we will multiply the first row and the first column. So note here, first row and the first column. So if the name of this matrix, let's say, is something like D, so the first entry will be D11, means first row and the first column. And then we will multiply the second row at the first column. So I'll get the second entry as 2, 1. So these are the two entries we are looking for. So how will we find them? Well, I multiply the first entry here with the first entry there. So I get 1 times 1, which is 1, plus also 2 with the 2. So second entry with the second entry. Now by chance these are the same, but not always these will be the same. So 4 plus 0 times negative 1, so 0. So this is just the first entry. This will be a scalar number. So eventually this will become 5. Now what about the second? Well, I multiply the second row with this column. So I end up getting 3 plus 2 plus 3. So 8. So this is the result of A times C. So next, what about A times B? So the size of A is 2 by 3 and the size of B is 2 by 2. So not possible. So we cannot find AB. What about BA? So the size of B is 2 by 2 and the size of A is 2 by 3. So yes, we can multiply. Yes, so we can multiply this. So will be equal to, so I'm going to write the B negative 1 2 0 1 and then A. So always remember, whatever is on the left is you are going to put that matrix first, and then whatever is on the right, that matrix on the right. Now you cannot reverse them. So A is 1, and then so now 2 0 3 1 negative 3. So it's always good to put like a arrow going horizontally on the first matrix, on the left matrix, and a vertical going down on the second, just to remember that this is the way we are doing it. So note that the resultant matrix will be of order, whatever is left here, 2 by 3. So the resultant matrix will be of order 2 by 3. So 2 by 3 means there will be 2 rows and 3 columns. So this is how it works. We take the first row, multiply by the first column here. So first row, first column. So where should the entry be? If you make a skeleton here, first row, first column. So here. So this place. So this will be negative 1 times negative 1, negative 1, plus 2 times 3, so plus 6. Now first row and second column. So this is the second column. Now I will multiply the first row with the second column. So I will end up getting negative 2. So first row, second column. So where should entry be? It should be over here. First row, second column. So I get negative 2 plus 2. Okay. The next one now, we still have one column left here. So first row, third column. So we'll get an entry here. So we get 0 minus 6. Now there are no more columns left. So and the job of the first row is done. Now we'll look at a second row, which is 0 1, and multiply with each column. So second row, first column, the entry goes here. So this will be 0 times 1, 0, plus 3 times 1, 3. Then this next one is 0, this second column with the second row with the second column. So we entry is over here. So second column, second row. 0 plus 1, and then the second row and the third column. So we are over here. So entry here. So 0 times 0 is 0, 1 times negative 3 is negative 3. So that the answer is 5, 0, negative 6, and 3, 1, negative 3. Okay, so then in the same way, let's see, can we find BA? Yeah, we did find BA. AB was not possible. What about CB? C times B. Can we find that? C times B. So what is the order of C? The order of C is 3 by 1. And the order of B is 2 by 2. So this is not possible. Okay, so this is how we do the matrix multiplication. So we'll talk about the other stuff in the next video.